Ah, but they're tube watts.
Take this, brother. May it serve you well.
Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster, giving you a video through a bit of a cold today. Let's talk about tube watts and why people will sort of make excuses for low power as long as it's tube power. Because tube power isn't any more powerful than solid state power, but you can get away with a lower power tube amp given a certain set of speakers than you can solid state. And why is that? The answer is pretty simple. It's soft clipping versus hard clipping. Hard clipping introduces lots of high frequencies that can damage your speakers. Soft clipping, typical of tube amps, introduces less of those high frequencies that can damage your speakers. It's that simple. But let me break it down and talk about why you might want more power even if it's just tube power. Because all right, so watts are watts. First of all, watts are watts. Tube watts aren't going to be any louder than solid state watts, but you can turn up a tube amp to closer to its maximum wattage without damaging your speakers. And when we talk about what kind of wattage you need for a given pair of speakers, that's often the concern. You can blow out speakers probably more easily with a low-powered amp, especially a solid-state low-powered amp, than you can with a high-powered amp. You know, obviously, yes, you can put more solid-state clean wattage into a speaker than it can handle and it'll fry it. But you can also fry a tweeter, especially by putting in lots of high frequencies through distorted sound. So what am I? What is it? What the friggity frig? Okay, distortion. First of all, just distortion. What do we mean when we say distortion? I mean, obviously, we mean anything that's not the perfect original waveform, something that's distorted from that. But the typical form of distortion that you get in any amp is clipping distortion. And the ultimate distortion, and when you turn your distortion pedal gain all the way up, you're creating a square wave. So you're cutting off the tops and the bottoms of your signal, of your sine wave. So the nice pure tone is a perfect sine wave. Cut off the tops and bottoms, that causes distortion. In solid state amps, it clips when you just hit that voltage rail, and it clips quite abruptly. And that's hard clipping. It just comes up and that tight corner there, tight corners in a signal mean high frequency components. And typically you won't be able to hear them. Not the highest ones, of course. You know, those will be ultrasonic, but that doesn't mean they're not getting to your tweeter. So you give a lot of that hard clipping to your tweeter and you can fry it. You won't be hearing, you're turning up the volume because you want it louder. Okay, it might sound louder, but it'll also sound more distorted, and ultimately probably going to fry that tweeter because you're just dumping all sorts of high frequency harmonics into that tweeter and overheating the speaker coil, the wires, and ultimately causing them either to literally burn up, but more likely to get hot enough that they melt or just break down the enamel on the magnet wire that keeps the wire insulated from other bits of the wire in the coil. And once you do that, then you shorted it out and it's not going to function as it should anymore. So that's how you kill a speaker with a low wattage amp. So that's one reason you want higher power for certain speakers. Like, I've been told by a couple of people who used to sell hi-fi gear and specifically used to sell Dahlquist speakers that my Dahlquist DQ10s really would benefit from a lot of solid state power, 200 watts and more. But then when I mention, or it's brought up, well, what about, say, a 60 watt per channel tube amp? Oh, yeah, that'd probably sound pretty good. And that'd probably do fine. And that's because when the tube amp clips, it doesn't produce as many high frequencies that can damage the super tweeter on those particular speakers, but in tweeters in general. So that's one reason you want more power for a given pair of speakers. You know, if your speakers can handle some high wattage, then you might want to be able to give it to them, especially if you're going to want to listen that loud. Now, here's the thing. You might say, well, I mean, nobody really listens to stuff all that loud, right? I mean, you know, if you're listening to, on most speakers, if you're using 10 watts of power, that's freaking loud. And that's true at an average level. But that doesn't mean that you don't maybe need more power in order to listen to an average sound pressure level produced by 10 watts of amplifier output power. And this is where we get to the concept of headroom. Headroom means I can be listening to loud music, maybe, let's say, at 10 watts, which is going to be pretty friggin' loud. Some of the drum hits especially, if it's not very compressed, if the drum track in particular is not very compressed, those drum hits, especially the snare hits, are going to go up to very high volume, but very quickly, and then come back down very quickly. So 10 watts on average, your snare hits might go several dB higher than that. 3 dB, 6 dB higher. That is 2 or 4 times as loud as the average level. Now, 2 or 4 times as loud means 2 or 4 times the power. So if I'm listening to my Beaver Valley at 10 watts, well, the drum hits that come over there that hit it like, 2 or 4 times the power, they're not going to sound 2 or 4 times louder through my speakers with that amp, because that amp only does 10 or 12 watts. And so it'll just clip those snare hits. Now, because it's a tube amp, the clipping of those snare hits won't introduce all sorts of awful high frequencies and damage my speakers. At least not as much as if it were a solid state amp. And so I can get away with a lower power tube amp and still listen at relatively high volume, because those are tube watts, which are no louder than solid state watts, but when the higher wattage components of the signal are clipped, they're not as damaging to my speakers. And so I can push that tube amp harder than I should push a solid state amp on the same speakers. All right, I'm going to show you tube clipping. So this is the Beaver Valley amplifier, and I've got it hooked up through this little Kinter amp over here to my signal generator app on my phone. Jeez, I've got like a couple of different signal generators up here that don't actually work. Anyway, point is, we can see up there on the scope the waveform, just a simple 1 kilohertz sine wave. And we're pretty good power here. I'm going to crank it up. Hear that hum? That's the actual heater coil that I'm using as my dummy load humming. That's why reverb works. Alright. Now we're getting to clipping. So this is maximum power, and as I push it a bit, it distorts, and it can distort a lot. Now you see the crossover distortion coming in. But the reason people talk about tube watts versus solid state watts, at least one of the reasons, is that clipping that we're seeing right there isn't really all that hard. Tube clipping is softer in general. And even prior to clipping, we can see that the bottom of the waveform is a bit squatter than the top. So that's also an artifact of tube distortion as we get to higher power. And turns out that kind does tend to sound kind of cool, kind of nice. Now, that doesn't sound nice, but that part right there, that's not going to be so bad if it's just a snare hit. It's going to lop off the top of that snare hit, but it's not going to generate all sorts of wicked high frequencies that are going to kill our super tweeter. And that's why we can get away with lower power with a tube amp without damaging our speakers. And so when I switch to this Heathkit amp that I've got up there now that has 4 times the power of my Beaver Valley, then I listen to Metallica, which is not very compressed. It sounds a lot more impressive because, yeah, it's loud. And then those drum hits on top are just like, whoa! I can hear how much louder they are than the rest of the track. It's pretty cool. And that's why you want more power. I mean, maybe you want more power, but if you do want more power, that's the main reason why. Is so you can hear that full dynamic range and still listen at pretty loud volumes. Because you crank up a low power amp and it'll be loud, but it'll be compressed. And if it's a solid state amp, it'll sound pretty awful with that compression because you're hard clipping the tops of those high magnitude waveforms. And a tube amp less so. Tube amp's still not going to sound great when you crank it up way past its failure point or whatever. Especially on the bass end, with a lot of tube amps you can really kill. That bass can really go to hell if you have a more budget tube amp with smaller output transformers. And here, for reference, is the Beaver Valley. All right, first the constant volume test. All right, let's try cranking it. All right, we're going to try this again. Now we're plugged into that solid state amp down there, the Big Linear 200. Just kind of crank the volume both times because, this is one of those songs you got to kind of pump it up, crank up the volume to, right? So let's try this. So yeah, I think the Beaver Valley was a demonstrator there of what happens that we can crank it up pretty loud. I mean, kind of about as loud it seems like as I got the 100 watt per channel amp. Now with the 100 watt per channel amp, once I got it up loud enough, I started to hear a little distortion. Now when I got the Beaver Valley up loud, I started hearing quite a bit of distortion. But oddly enough, it didn't sound all that distorted till I got it really loud. And then, when the big loud vocals came in, it just sounded really compressed. And then after a bit, pretty damn distorted too. So it'll be interesting to see what that looks like on the waveform. So Let's check that out. Here are 4 clips of Master of Puppets ported into Audacity. So what have we here? On the left we have 2 clips played with the Beaver Valley amp, and on the right 2 clips played with the Phase Linear 200. The clips on the left of each pair were played at approximately the same modest volume. The clips on the right of each pair were cranked. And then I've gone in after and amplified all 4 clips so that the peak magnitudes come out to 0 dB. Okay, so this scale goes from -infinity dB up to 0 dB, and it's a full waveform, okay? So you can see, for example, here's peak at 0. There's peak at 0. Peak at 0. Peak at 0. Peak at 0. Now, what you will notice is there's a lot more air in this one than this one. But these two, I mean, maybe this has a bit more air in it. They're not exactly the same points in the music, you'll hear, but pretty similar. And when we listen, we'll really notice the difference in apparent volume between this one and this one. This one will sound much louder, but the extremes aren't as much louder than the rest of it. So this one is effectively compressed. So let's just play all 4 clips. So, I think the difference between these two was pretty obvious. This one sounding way more compressed and sounding louder, but the loudest bits not sounding much louder than the rest of it. And that's what we mean when we say headroom. These two were played at approximately the same volume in the room. These two, it's harder to say because I cranked it up until it started to sound obviously distorted. And so this one is going to be a bit compressed because I think even this one I cranked up so that there was probably a little bit of clipping. But what we can see is that the headroom that the 100 watts per channel gives us is real. That's what we mean when we say headroom versus not so much. And that's why, if you're wanting to listen at high volume, it's helpful to have those lots of watts so that you're not compressing the hell out of it and potentially introducing a lot of distortion that's bad for your speakers. Now with the tube amp, it doesn't produce as much nasty distortion as we would get if it were the solid state. Alright, same 4 clips, but now I have taken each of them and normalized them to the same perceived loudness, and then amplified all of them together so that the peak magnitude is 0 dB. And let's listen to here. So again, these are both the Beaver Valley amp, the 10 watt per channel amp. These are the Phase Linear 200, the 100 watt per channel amp. And so they all sound essentially the same loudness now, but you can really hear now how much more compressed this is than this. You can also hear that this is more compressed than this, but it's a less dramatic amount of compression. Yeah, that's the tube watts. Oh, but they're tube watts. Yeah, that's what that means. And maybe when people say that, oh, but those are tube watts, they may not really understand all that. And I think probably most of the time they don't. I think most of the time they sort of think of tube watts as somehow louder than solid state watts. And they're not. No, watts are watts. Power's power. Energy's conserved, and all that. Now, another aspect of, those are tube watts, is that solid state power is a lot cheaper than tube power. For a lot of tube power, it just gets really expensive. For a tube amp to put out, say, 10 volts RMS on the output, that 10 volts RMS is what's on the secondary of the output transformer. The primary side has much higher voltage than that. So the primary side's going to have maybe something like 300 volts. Power transformers capable of delivering high voltage just get way more expensive. And it's just a fact of life with tubes that to deliver really high power in general, and there are always exceptions, and there are ways to sort of get around this. There are output transformer-less tube amps, but your normal tube amp with an output transformer has to generate really high voltages in order to get modest voltages on the output, and that high voltage is expensive. And the tubes that are capable of handling that high voltage and delivering that power are also expensive. So, you start to get these Mondo big, the KT88s that are pretty big, and the KT150s that are bigger and, beefier. And the output transformers that can handle that power, get big. And of course, the power transformers capable of supplying that power get big. And now you've got a big hunkin' tube amp that's pretty expensive. Whereas with a solid state amp, of course it's still more expensive to produce more power, but it's not, the costs don't go up as steeply as with tube amps. So when we say, those are tube watts, maybe also part of what we mean is, we can't really expect a tube amp, the 200 watt per channel tube amp is going to be crazy expensive. Whereas, you can get a 200 watt per channel solid state amp for not all that much money these days. It may not be good, but, you can get it. And so part of what we mean also when we say, those are tube watts, it's like, a 10 watt per channel tube amp is still going to be, if it's a good 10 watt per channel tube amp, it's still going to be pretty expensive. And if it's a 40 watt per channel tube amp, it's going to be a lot more expensive, and so on. It's partly a matter of expectations. So we can't really expect, any random schmo to have a tube amp that can crank 200 watts. Jesus. His stereo only has 10 watts per channel? Yeah, but those are tube watts. Oh, yeah. I get it. Now, again, I don't know if everybody means what I say that sort of means when we say, but those are tube watts, but they may still have a feeling that somehow tube watts are louder than solid state watts. And they're not. But you can push a tube amp harder, so you can get more decent sounding volume out of a low power tube amp than you can a low power solid state amp. So, to some degree, there is something to be said about this, but those are tube watts. It's not a total ridiculous thing to say. But now if somebody says, but those are tube watts, and now you can say, but those are tube watts, in an educated way, in a sophisticated, nuanced way, and an understanding. If the watts are still watts, but tube watts. All right, have fun, everybody, and I will talk to you later.